Hey guys, we're going to talk about how to find equations for exponential functions. And we're going to review some of the basics from algebra that you might remember from that course. And the biggest idea with the exponential function is that the base is being multiplied. So exercise 1 talks about an example that is from algebra. And they want you to come up with the a and b values for the equation. Okay? And to find those, a is the y-intercept. So if we're talking about an exponential function, a is the y-intercept, and then b is the multiplying factor. So what you're multiplying by each time. It's kind of like the slope, but in slope it's constant change of addition, and with exponential functions it's constant change of multiplication. So what are you multiplying by each time? So in this case, the y-intercept is going to be, from this point, it's going to be 5, because you have 5 as the y value. And then to get to each next answer, what you're doing is you're multiplying each one by 3. So b is going to be 3, and when you write the final equation, it'll be f of x equals 5 times 3 to the x power. So 5 would be your y-intercept, and then every next value you would find by multiplying by 3. Now we're going to look at a couple other examples. So exercise 2 kind of builds on what we just talked about. And the big idea with exercise 2 is that they give us a point on that graph to determine the value of a. In this case, if you put in 0, you get 8 out, which means if I'm talking about this function, if I'm talking about f of x, and we know that we have the point 0, 8, that means that the first value is going to be 8 for our y-intercept. Then it says use your answer from part A, and the fact that we know, well, we have 3 and 1,000, another point, to figure out what b is going to be. So there's a couple ways to do this. We know we start at 0, 8. Now there are other x values that are in the way to get to that 3, 1,000. But the trick is, again, you are multiplying by the same number each time. And if you have to do that 3 times to get to 1,000, that's how you would figure out what number it is. The other way you can do it is you could take out the f of x and x and put in those values. So you could put 8 times b to the third, and then put in 1,000 for f of x. So to do this, what you would have to do, divide each side by 8, because you're trying to isolate that variable. And when you do that, you're going to have b to the third equals 125, and you can get rid of that third root, cubed root, by applying cube roots to each side. So in this case, b is going to end up equaling 5. So to solve for the value of b, which we just did, so this would be our equation right now, 8 times 5 to the x. And if I want to do the value for f of 2, I would do 8 parentheses 5, and then put a 2 in for the exponent. Okay? And in this case, that would give me the answer of 200. So I'd get 200 out for this one, which would be 200. So, moving on to exercise 4 on the back. Similar type of question. However, they don't give us the y-intercept value. They give us 2 other points on the graph. So to do this, what we're going to do is on part A, it says we're going to substitute those into the general form, kind of like we did with exercise 2 on the last page. So I'm going to go ahead and I'm going to substitute those into this general form. And again, I have x and y values. So I'm going to go ahead and do 30, well, I'll do the 121.5 equals ab to the, in this case, 5th power for an exponent. And then we got 36 equals a, b, and then squared. So what's going to happen now, it says we're going to, in the question for b, divide these 2 equations. So that's going to do 2 things. It's going to divide and cancel the a's out. So these a's are going to cancel out if we divide these 2. So imagine putting a big fraction bar in here and dividing everything by everything below it. A's will cancel out. We'll end up with b to the third, because we'll subtract the exponents. And then what we got to do is take our calculator, and we got to do 121.5 divided by 36. And you get 3.375. So equals 3.375. Now I got to get b by taking the third root. So a cubed root of 3.375. So I'm going to do the math button. I can do a cube root with option 4. And then 3.375. Which means that b is going to be 1.5. So that's our multiplying factor. Or multiply each time. So, right now as it stands, we do have y equals a, b is 1.5, and then the exponent's x. So, I still have to solve for a, and that kind of goes into part D. And I'm going to solve for a by using one of those points again. So I'm going to use this point. I'm going to do 36 equals a, and I'm going to do 1.5, and then the exponent would be 2. So to do this, I'm going to have to square the 1.5, which is going to be 2.25. I'm going to stick that a at the end, because I usually put the number before the variable. And then I got to divide both sides by 2.25. So a equals the division, the quotient of 36 divided by 2.25, which ends up being 16. So the equation for this, a is 16, and our equation is going to be 16, a multiplying factor of 1.5, and then an exponent of x. And because it's an equation, I can go ahead and I can type in that equation, and my goal right now is to check the calculator. So I see 236, and the other one was 5 and 121.5, which both of those points, you can see right this chunk of the table, both of those points are there. So do make sure you check your equation after, because it should contain the point or points given to you. And just be careful when you are dividing, because again, like we talked about before, you're going to be subtracting the exponents like it says on exercise 4.